Hello, if asked to find all values of m and n that satisfy this math expression, maintaining the fact that m, n are all positive integers, how can you solve this Ukrainian math question? Let's sign out. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified math content. Now, to solve this expression, remember we are asked to find all positive integers of m and n. We're going to suppose that 2005, which is the numerator over there, is divisible by root n. So if 2005 is divisible by root n, if 2005 can be divided by square root of n, then we can conclude that our 2005 can be equal to a constant multiplied by n. Now this constant is one of a factor. K is a factor of 2005. Now if we simplify that, what we are simply going to derive is an expression making k the subject of formula. Now let's take the square of both sides. If we take the square of both sides, we can be able to clear that square root, and this will be equal to k multiplied by the square root of n all squared. So what is this going to give us? This is going to give us k squared n, right? And this is going to give us 2005 what? 2005 square. Now from this expression now, you can be able to see that the value of our k can simply be equal to 2005 divided by root n. Now I want us to take note of this expression because it can be valuable as we solve this expression. So if 2005, if k can be equal to 2005 root 7, that means we can be able to replace the value of k with this expression, this whole expression over here. So if we use that value of k, that expression can now give us the square root of m, right, plus k will simply be equal to 2006. If we simplify that expression, we'll have the square root of our m to be equal to 2006 minus k, right? Remember, we are all asked to find the positive integers of m and n. So if I want to find the value of m here, what I simply need to do is to take the square of both sides. And if I take the square of both sides, I'll have my m to be equal to 2006 minus k, and all this will be what? Will be squared. So I'll consider this to be equation 1. So whatever I insert there, I can be able to find the value of my m. Now from the original expression given to us there, we can see from this initial expression asterisk, I can be able to find the value of my n here, right? From that expression, the value of my n can be equal to 2005 square, right? Divided by k what? K square. Now the value of my n can simply be equal to 2005 divided by my k, and all of these can be what? Squared, right? So I'm going to consider that to be equation 2. Now if I simplify this, I can be able to get the value of my k. Now when you look at 2005 from that expression, 2005 can be able to give me some possible values. What are some of those possible factors of k from this expression? 2005 from this expression can simply give me 2005 can simply be equal to 5 multiplied by 401, right? So from this expression, I can simply derive some possible values of k, and you know that if I can derive some possible values of k and insert it over here and here, I can be able to find my values of m and n. So if I assume some values of k, the possible values of k can simply be 1, right? K can still be equal to 5, because 5, when we consider this and this, k can still be equal to 401, because if I divide this, I can be able to have positive integers, and k can still be equal to 2005. So if I insert all that here, I can be able to find the value of n. Now let's try that. For the first expression, we're going to consider the value of our k to be equal to 1. Now if k is equal to 1, then from that expression, considering equation 1, the value of my m will now be equal to, recall that my equation 1, my m is equal to 2006, right? That is 2006 minus k all squared. That's the value of my equation 1. So if I insert the value of k to be equal to 1, then I'll have my m to be equal to 2005 square, right? And then my n can be equal to, inserting the value of 1 into this expression, I'll still have my n to be equal to 2005 what? Square. So what if I insert the value of my k to be equal to 5? With my k equal to 5 into this expression, I can be able to find my m to be equal to 2001, right? 2001 square. And my n can be equal to 2005 divided by 5, and that is going to give me 401 square. So this is an expression I can get for the value of n, of k equal to 5. Now what if in another expression I have my k to be equal to 401? In that expression, then my m can be equal to, if I insert the value of my k to be equal to 401 here, then the value of my m will be equal to, the value of my m will be equal to 2006 minus 401. That expression will simply give me my value to be 1605 square, right? And if I insert that into the other expression, that simply will give me a positive value of this divided by this, will simply give me what? 5. So I'm going to have that to become what? 5 squared. So finally, if I have my k to be equal to 2005, these are possible values of k, then my m from this expression will be equal to, insert the value of m here, that will be equal to 1 what? That will simply give me 1, right? 1 square is 1. Then if I insert the value of 2005 into this other expression for n, then the value of my n will still be equal to 1 square, which is equal to 1. So all these are simply values of m and n. I can derive values of m and n I can get, assuming the value of my k. The possible values of my k is 1, 5, 401 and 2005, which are all factors of that what? Of those expressions. So these are possible values of k I can get from simplifying that expression. I know you did get what we saw in this question, and I know that you do enjoy watching this. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Thanks so much for watching, and bye bye for now.